Then, hello everybody. Good morning. Welcome to our seventh X Technology meetup. What is X Technology? Well, we are a continuously growing group of people, mainly from the tech sector. We like to learn about new technologies, and we build our own projects in different languages, and we discuss about it. We meet every other week on Saturdays, like today, 10 a.m., and discuss challenges and ideas. And you're invited to discuss with us, actually. Please give us messages, and we will pick them up and ask them to the one who is presenting. I'm your host today, Sebastian, and I'm really excited for the session. So what will be the setting today? In the first half, we have Igor speaking about his project, analyzing Airbnb data. Alex, Maxime, and me, we will discuss together with you. And then Maxime will follow introducing his project with a focus on tech-driven investment decisions. And I'm very excited for both talks today. I would hand over the word directly to Igor to give a little bit of an intro of yourself and then of the project.
Yeah, thanks, Sebastian. Great intro. So yeah, I'm Igor. I work as a data science for the last 5 or 6 years, and currently I'm located in Vienna, Austria, and work for a company, Crayon. Actually, we're colleagues with Sebastian. That's awesome. And yes, today I will continue talking about the project of mine, which I called Airbnb Analytics. And we will start from the small recap of where we stand and what happened during the previous sessions and what it is exactly. So Airbnb Analytics, that's the educational data science project. My idea was to build some project from scratch. I also put the toy in parentheses because it's not really a project which solves some business needs, but it's more like for education and learning the new technologies and things. So this project has a couple of steps. The first step is to get some data, because sometimes you already have the data and you have to analyze it and build some machine learning models, but that's not what I wanted to do. I wanted to start from scratch, from getting the data, the raw data. And I'm fond of tourist domain, let's say. I'm very fond of planning my trips personally. And that's why I picked Airbnb website to get the data from. So the first step of our project was actually parsing the website of Airbnb and getting the raw data from them. We already had 2 sessions. The first one was about parsing the static web pages. The second one was about parsing the dynamic web pages. And after that, we managed to have some, let's say, example of the data. So I will quickly shift here. So that's how the data looks like after we parsed it from Airbnb website. It's sometimes quite dirty, not unclean. So there are strings with a lot of useful probably information hidden within. There are different signs, parentheses, empty spaces. There are also concatenations, which I introduced to make our parsing a bit easier, and so on. So the data is not really ready to be used in machine learning, which is our next step. So today we are going to clean it and make it a bit neat and ready for the next step. And as I already said, the next step will be machine learning. So we'll build a model, which currently I'm thinking of the model which will predict the price of the listing based on the feature of the listing. So it will basically tell you if the price of a particular accommodation is too high or too low. And hopefully it will help you decide where you should spend your vacation. And the next part will be building some tool out of this model. So currently I'm thinking of some web extension. So basically you get to the Airbnb website, you browse through locations, and this extension will help you decide whether the price is too high or too low. And so, yeah, that is kind of probable part of the project. The next one, I would like to make this not really sitting on my local machine, but probably put it on some, I don't know, cloud or somewhere else and create some pipelines so that it works automatically and not with me typing something in IPython notebooks or doing Python.script. in CLI. So some automation would be nice. And basically, yes, so let's jump for today's session. So the goal for today is to make our clean data happen, and we will do it with mostly pandas. Pandas is a very famous library in Python, which most of the people are using when they work in data domain, let's say. So yeah, and this is a typical import. I think a lot of data scientists start their usual work on or any script or any analysis from importing these two libraries, pandas and numpy, and we will also start from this. And actually, I would like to import some other libraries which we will use a bit afterwards. And today I want to split the talk a bit like in 3 parts. So first of all, I will talk about some simple operations, so how we will use strings, data frames, lists, and so on. What can we do with them? And then we will jump a bit to the problems which we have while parsing our real data using these simple operations, and then we will talk about the results. So yep, let's jump in. So just simple things with the strings. What could we do with the strings? Let's say we have this string which contains some information which we might need, but it's in one string concatenated with some symbols. And the easiest way to split it is, of course, to do dot split. So that's why I love Python, because it's mostly like speaking English. If you want to do something, you say, hey, Python, do something. Hey, Python, split. And it splits the string into the list. And in the list, you have the values which you are interested in. Next method is replace. It's close to it, but let's say you want to replace our current concatenation symbol with some other different. You also say, hey, Python dot replace. And we have a new string where the concatenating symbol is substituted. Another function method which we might need is called starts with. So basically we have the string, and I would like to know whether it starts with rand or maybe it starts with rand capitalized. Let's run it. And yeah, in the first case, it says yes, true. It returns true. And in the second, false. So that's how it's probably the easiest way to check the symbols of the first symbols of the string. Cool, that was lists. Oh, strings, sorry. Now let's jump to lists. One thing which is cool about Python is a list comprehension. It's actually not a functionality, but I think it's called a syntactic sugar. So what it is, let's say we have the list of 5 values, 5 numbers, 1, 2, 3, 4, 5, and we would like to multiply all the elements by 10. So the easiest way to go is to create a loop and iterate through all the elements and say, let's multiply all of them by 10. And of course it works. But in Python, there is another way, which is quite smooth and, I don't know, beautiful. You create this type of construction. You say that, hey, for every element I in my list, I would like to do 10 times I. And you put everything to square brackets. And it will create a new list, which contains, yes, all the elements multiplied by 10. Great. So when there are single comprehensions, there are also double comprehensions. Let's say we have a list of lists. There is a list of animals and a list of furniture. And if we do just a simple comprehension, we will take the same list back. So we say just give us every element for every element in the array. So it will just show us the initial array. But sometimes we would like to flatten this array. So we would like to unnest it to make it one-dimensional. And for this thing, we will need double comprehensions. So we will say that, hey, for every element in the initial array. And then we add the thing that for every sub-element in the elements from the initial array, return me sub-element. So this construction should return us only one array with all the values which were hidden beneath the nested elements in the initial one. Great. So this one we will also need. And maybe the last thing which we will use today for lists is finding the unique values. Let's say we have a list of some letters, and we would like to know what are the unique elements of this list. And in Python, there is this construction set. And it basically, if you apply it to the list, it will output you the unique values of this list. So it's the quickest way to define the unique values.
Thank you, Igor, for for this setup already. Probably for Maxime, this is no big news, and for many of our viewers also maybe. But for me, some of this is a bit new because, or it's a good refresh at least, and also because of the many string operations. So how often does it happen when in your regular work that you have to work with string data and text data?
Well, I'd say it happens almost every day because most of the data is either a number or a string, a category. And sometimes you would like to, if you would like to analyze the data, then probably you have to process your strings, at least to create some dictionaries out of it, or probably clean the strings from unnecessary data. Or or do the splits as I did here. So basically it's usual stuff.
So it's your daily work, basically, to some extent.
Yeah, kind of. So
Very good.
all right.
Right.
I'm wondering if you showing now a real processing of data, because I mean I would not expect a dog, cat, or elephant to be in an Airbnb website. Is that?
Yeah, you're right. So that is of course a play example, but afterwards we will do the same for the Airbnb data. So
Okay.
I probably was I wanted to create the fast array from my head. It was.
For everyone for anyone who has a question, please drop them in the chat. We will ask Igor eventually.
Great.
Great.
Yep. So the next thing which we would like to look at is data frames. Data frames, it's a very nice construction in Python, which came from R language, I suppose. So usually when you work with the data, you have both numerical and categorical data. So categorical means some data with text. And to be able to put it to the further steps, meaning some machine learning model, you mostly have to at first analyze it all together and then probably do a lot of processing. And the data frame is a nice construction which allows you to work simultaneously with both strings, numbers, everything, and it is quite handy. So let's load one of the data frames which we parsed before. So it's the data from Meyerhofen, from Airbnb. And that's how it looks like in a data frame. And basically, there are a lot of different columns with values. And we can scroll through them. That's awesome. So now we would like to introduce, I don't know, some most important functions and methods which we will use today. So first of all, the missing values. So sometimes this data frame has these values which are not a number. I suppose, the closest one will be here. So there is a column refundables, and sometimes it has the value, and sometimes it says not a number. So the value is missing. And there is an easy way to show us. So there is a function is an NA. It tells us whether the value is null or not. And you see that mostly it's false, meaning that it's not empty, but sometimes it's true. So here we have empty values. And there's also an easy way to aggregate the totals, so calculate some.
Igor.
Yep.
Igor, can you hear me?
Yeah.
There was a question in the chat. I will put it up here. Maybe you can see it from Michael. He's asking if after multiple list or dictionary comprehensions, you start to lose readability. What do you think?
Yeah, I totally agree here. So that's Python is good that sometimes you can create a huge one-liner and put everything there, but you have to be very careful not to make your code unmaintainable and unreadable. So I totally agree. If it's a very simple array of arrays, like 2D array, then probably it makes sense to create this double comprehension. But if you're dealing with something more like something bigger, like 3D structures, then probably it makes sense to just do a simple for loop, just to make it easier to maintain. So I totally agree here.
Makes sense. He also mentions he's just using one of that comprehensions, as I understand. All right, thank you, Michael, for the question.
Yeah, thanks a lot. Great. Yeah. So as I said, so there is a way to to calculate the totals of this missing numbers. So we can just basically say dot sum, and it will sum all the missing values and show us the outputs. And we see that there are some columns like specialties 1 and 2, which had a bit of empty values, and also a couple of others. There's a vice versa function which tells us which values are not missing, and it's kind of not an A. So before it was is an A, now it's not an A. So as I said, Python is like speaking English. And it will be the other way around. So 60, that's the total amount of the lines in the data set. So 60 meaning all of the values are not a null. And for some, we have a small amount. Great. So what can we do with these empty values? We can, of course, fill them with some values. So let's look again at our refundables. The first value is present here. The others are missing. And we can do just simple, hey, fill NA. So fill the missing values with the value, which is arbitrary here. And it will put this value to all the missing values. Another function which is quite close to this is replace. So it will not fill the missing values, but it will replace the ones that we don't like. So for example, we have the facilities column here. And now I'm saying, hey, replace all the columns where the facility equals kitchen to the bathroom. Basically, yeah, now I have a lot of bathrooms. And this kitchen was not replaced because it's a part of the string. It's not the whole string. Good. So I think that's almost it for the data sets. Only one thing left. So data sets also contain the strings, and we could work with the strings as we were working before. And to do that, we say we get the column and we do dot string. And now we can work with it with a simple string. So for example, we have this column rooms on top, and we would like to split it the same way as we did before. So we do a dot string, and now we can do dot split as we did before. And it will output us the row which contains the lists for every rooms element. And the same we can do with starts with. So we can take the facilities column and say, hey, whether it starts with a kitchen or not. And it will be true, 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 false, because the last one does not start with the word kitchen. Yep. So another thing which is quite handy for data frames is the function apply. So it basically applies the same function to all of the rows of your specified column. So here we take the column header and we apply this function to all the columns. So basically we split the string. And I'm sorry. So that is just one of the ways how to apply the same function to all of the values in one particular column. And what is also nice about this function that we can use the lambda function in concatenation with apply. So what is a lambda function? Of course, there exist normal functions in Python. So you say define function, which we called func normal, and it outputs 2 times the input argument. And the same could be done with this small string. It's a kind of a one-line definition of a function. We say, hey, lambda x return 2 times x. And they work the same, so we can see that they return the same output. So it's quite handy to use lambda function together with apply. So that way you could do a lot of with your values in the different columns of the data frame. So here we again take the header and we apply the following function. It looks a bit not readable. That's the comment from Michael before. So I will try to understand what it makes. So at first it says, hey, so x is our input variable. That is the value of the data header column. So every row. And we say, hey, let's split it first. And then we say that we output 1 if in this split list there is the element house. Otherwise, we output 0. So let's run it. Basically, this is a string. If there is a house, we output 1. If there is no house, we do 0. Great. So next thing is regular expressions. So hopefully we are not too fast because, yeah. So if it's too fast, please guys interrupt me and we will talk about some other things like the weather. So anyway, the next thing is.
Yeah, I actually, sorry, I actually had some additional about this this lambda function in here. Is that is it kind of ternary operator in Python, or it's I'm not a Python expert, as you can imagine. So that that looks indeed a very strange expression to me.
I think I missed the word. Which kind of operator?
Ternary, you know, like a
Ternary.
question mark. Yeah, a question mark. If like if the statement is true, then it's the first branch, or otherwise after the semicolon it goes the second branch.
I think I probably cannot answer a question. Maybe Maxim could, because I'm not sure what is a ternary operator.
Yeah, so I believe the structure here, like this particular lambda function, is kind of like ternary operator, but actually lambda function may contain like whatever code you'd like, and the difference is that it's not like named, and it does not have a name, and it does not belong to any, does not have any reference to any variable. So basically you can store whatever you want in lambda function, but this particular is, yeah, kind of like the ternary operator, but written from the scratch.
Yeah, I think I got it now. Thanks for explaining.
Yeah, Michael says that, yes, it's a ternary operator. So approved.
So you're mainly using operators or functions like the lambda function and apply to make vector operations. Is this correct? Instead of like applying a function over the entire data set or an entire vector.
So basically,
correct?
Yeah, I think I'm using apply when there is no other easy way to do the vector operation over the data set. So if I can do something vectorized, I will definitely do it because it's much faster. Apply might be very slow. And if I think that I am okay with this slow speed, and if there is no other easy way to do the thing which I want, then I use apply. Yes.
Gotcha.
So yeah, apply might be really slow if you're dealing with some complicated functions and big data sets. So you should be careful.
And apply is a built-in method of array or a string? Is that
of a data frame?
So sorry, and the data frame is a part of a library, or it's a native?
Yeah, data frame. That's the pandas object. So
yeah, okay.
The main object which pandas operates with.
Yeah, got it. Thanks.
I would have one more question. Yeah, where you are right now, a little bit up eventually, where you showed the data exactly. For example, here when you split it for guests, bedrooms, and stuff like that, it seems like here you have an order in the data, right? Always guests, like the number of guests is first, and then you have the bedrooms, and then you have the beds and bath. So this is kind of complete already, or so you always have these four items, or?
Yeah, that's how we parse the data initially, because on the Airbnb website, this small substring is present on the search page. It always says you the guests, bedrooms, beds, and baths in this order. So here we don't even have to reorder it. It's always like this.
Mm-hmm.
We could use the
So
logic.
that's an easy one. Later on, we will have some missing values and stuff, or
yeah,
different orders. All right. Okay. Gotcha.
Yeah. So as you rightly mentioned, it's even if it's missing, then it says 0. So we don't even have to fill in the value. Quite handy. Thanks, Airbnb.
There is one
Yeah.
one more question. I will put it in the screen. Aditya, if I got this name, if I got the name correctly, can we change strings as factor, just like we do it in R? Good question. I would think about the same thing. Yeah.
Maybe you could specify it for me, Basti, because you work more with R. I'm not sure what is a factor in R.
A factor is kind of like for one variable a dictionary. So you transform it into numbers, kind of. It's like a mini bag of words thing. If I
Is it kind of in other languages, like you assign some simple value to whatever key? Is that something like that?
Yeah. Should be. That's I guess that's the thing. Yeah.
So basically, it's if you have the string of values, or if you have a list of strings.
So it would, for example, if you have if you have a one column would be only strings, right? And then you would use string as factor, means for example, the house would always be 1, and then it also represented as a number.
Okay, so it's one hot encoding kind of. So we will do it afterwards a bit.
All right.
So there are, of course, ways to do it. Yeah, if I understand correctly, what it is.
It's a built-in method in R, so maybe it's a bit different. I wonder how this works out then with one hot encoding. Well, it's an interesting question. Yeah, it's a tricky one. We got even more questions in here. Maybe I will bring up again one of Michael's question. I think it's solved already.
Yeah, he asks if we really need a apply function in here, or we can use something like a tuple to return x0. Well, yeah, I think he already figured it out that it's kind of needed in this particular case.
No, actually, I'm not sure if it's needed for this particular case. There might be the way to do it without the apply. I just wanted to demonstrate how we could use it. So in many cases, you could do something without apply, but sometimes you have to use it because there is no other way. But of course, there are options always.
It's nice to have this very live chat today. Thanks for all the questions. It's a good vibe, I think. Thanks.
I really like it, and the more the better. And yeah, so I will slowly move forward, and we can still discuss it. Yeah. So the next thing is regular expressions. It's like a very broad topic, and I don't want to jump really deep into it. So let's say we have the string, which is an email of Roger Federer. Hopefully he has exactly this email. And we would like to process the string and to get the name and the family name of the guy. So of course, there are multiple ways to do it. We could split it based on the @ symbol, based on the dot symbol, but there is also a way to do it with regular expressions. And how could we do it, for example? So first of all, there is a library regex in Python. We import it, and there are some methods, for example, find all. And what we have to do now, we have to create the regular expression to use it on the string. And here we created a pretty simple one. So it consists of 3 elements. So the first one is basically any symbol, any amounts of time. Then we say there should be an add symbol, and then again, any symbol, any amounts of time. And if we will run this function, it will output us 2 values. So everything that we put to parentheses will be the element which this function will look for. And it looked for it and it found. It said, yeah, hey, this Roger.Federer111 is corresponding to the element which we specified here in the regular expression. And this gmail.com corresponds to the second element of our interest. So basically with this technique, you can parse any kind of string and look for the information that you're interested in. And there are a lot of things you could encode into this string of regular expression itself. So for example, you could look for small case letters. So it's A-Z. Plus means that there should be at least one letter. You could look at any alphanumeric number. So it could be capital letter, small letter, a number, or an underscore. And there's, of course, much, much more. It's like a never-ending topic. It's like a huge one. But we will need only the basics. And I think the last element which we will utilize a bit today in the data cleaning is the library called itertools. So generally, it's a very useful library in Python, which is full of different methods around looping, iteration, cross products, finding elements, combining them in different ways. So all around this combinatorics, let's say. And we will use only one function from there, which is called group by. So let's say we have our facilities and we have a list like this. So it consists of a lot of elements. Some of them are similar. And we would like to know, first of all, what are the unique elements in this list, and also how many of each of them is there present. So it's basically doing the group by function in SQL. And one of the easiest ways is to apply the itertools group by. And again, it's the list comprehension, which looks not very readable. But after some time, I think you could understand it. So basically, this function creates a group by over our list. And we know that there are 51 elements of kitchen, 8 hosted, and 1 empty. Great. So that was kind of the end of the intro part. So we could still discuss some things about functions, or I can jump directly to use case, guys.
Yeah, there was actually one more question from the chat that I'd like to raise first, because this was still applies to the things you've been discussing up. Mainly, I think this is all about the apply, for example. So in case you have a really big data set, Sergio asks, would you still use these tools, or would you do something else?
Yeah, that's a great question. I think if we're talking about a really big data set, like the really, really big one, I would probably try to do the preprocessing even in SQL if it's possible, because SQL is very nice engine for doing all the kinds of preprocessing. It exists for like 50 years or even more, and it's already optimized as far as it could be.
This applies to string operations as well?
Some of them probably, because you can define your own functions, UDFs, user-defined functions. But of course, I will try to do simple stuff there. I don't know, for example, group by will definitely work better in any SQL engine than in Python. And I don't know, some things like filtering the values that you want, creating the lists, substring, strings, even regex, it all exists in SQL, so it could be done there. And I think it might be a bit more scalable. But also about maybe the apply function. So I will probably not use the apply function if I have a data set of, I don't know, a couple of million rows. Again, it also depends on the speed that you have to reach. If it's okay for you that the script will run for, I don't know, minutes or hours, then you could do it. If it's not okay, then you have to think about some optimization. But there is always a trade-off between how fast you want it and how, I don't know, maintainable the code is, or. Yeah, so something like this.
Makes sense. Yeah, and then one question from my side regarding, or a comment from my side regarding regex. I guess that's a science in itself to some extent. I have a really hard time understanding more complex expression in regex. So that's really hard for me, and I always try to use built-in methods wherever possible to come around this obstacle on my side. I don't know, how's it for you? Do you like to apply regex, or how's that for you?
Yeah, I don't know. I think I also try to avoid it when possible, but sometimes it's a bit faster way, because I can do something with, I don't know, two splits or three splits, where I can use one regex function. And yeah, it's up to the person. But I also, I don't know by heart all the elements and the special symbols of regex. I always Google it. So.
I can say that in programming, also people try to avoid regular expressions as much as it's possible. And even they have a pronoun, like if you have a problem and you try to solve it with a regular expression, then you have two problems.
Yeah, you're right, totally right.
I had some follow-up for the question that you were answering before. So if you prepare this data set on SQL side, can you think of like of course in terms of your project, like how would the whole flow would look like? I mean, is it gonna be some temporary second table that you're gonna prepare, and then can you think of problems you need to solve, to sync between these processes, like you process the data, you grab the data, then you pre-process for the second table, and then only then you run your script on the top of the second table. So I'm thinking, yeah, how basically your program will look like, how the whole application will look like in this case.
Yeah, that's great.
Yeah.
That's great. Yeah, that's what I'm also thinking about. Yeah, and I briefly started touching this topic. How I think it for now, there's a parsing part, and my idea that this parsing part should put the data into some, I don't know, staging storage or raw storage. And probably it makes sense to use something like MongoDB, because the data is mostly the huge strings or JSON dictionaries, and it will be kind of the raw storage. All the data will be just dumped there without any consideration. And of course, there might be some duplicates, because we might run the parser for the same location in different days, and it all should be stored there with some indices. And then there should be some, I don't know, interim or cleaner database where I would store the results of that kind of cleaning, for example. Yeah, so yeah, I think so. The two-stage approach might work here. So at first we have the raw data, then we have some preprocessing engine, which might be pandas with some additional libraries or SQL or combined. And then we have the database of clean values, which we will afterwards use for our project, meaning machine learning.
Thanks. Would be nice to maybe hear about that in the future sessions.
Yeah, that's definitely. I also want to do it, because now it's not like a productive project. Cool. Yeah, so that was some intro part. I tried to put all the small things which we will use today in cleaning the data. And now let's jump to the particular use cases from the data which we have. I will import a couple of data sets from 3 particular locations which we scraped. I will combine them into one data set here. And now we will apply some of the functions which we were talking about before. So let's say we have the column listings ratings. It's just a concatenation of all the ratings of the location. There are 6 different values. And initially we scrape them as one string concatenated by a specific value. And now we will just do what we did before. We will say, hey, it's a string, that string, and let's split it based on this concatenation. And we use these backslashes to escape the star symbol, because star symbol is a specific symbol in Python. Well, basically we apply this small data set, and we also want the columns to be named. And here we will just hard code it. We know that the rating in the Airbnb is always of these 6 values: cleanliness, accuracy, communication, and so on. And we will grab them and name the columns. So that's how it looks like in the end. So out of one column, which had concatenated string, we have now 6 different columns with values. And sometimes it's not a number when the initial value was missing. Next thing is a bit the otherwise. So we have to merge strings, not split them. So as we were parsing the Airbnb website, we were heavily relying on the CSS. And these CSS classes were sometimes changing in the HTML of Airbnb. And that's why I have this, I don't know, workaround. So I started with one CSS value and I downloaded it to the column specialties 1. But then they changed the CSS value and I started downloading it to a different column, which is called specialties 2. And I could not substitute one with another because this change was not. So in some cases, there was one case, and in the others, there was another value. So I had to download both of them and then preprocess or post-process. And basically, let's see at the missing values. So we see that both these columns have quite a lot of missing values. So actually, it's around 50-50 among them. And what we would like to do, it's basically like the function coalesce in SQL. We would like to pick the first non-missing value. So basically, we take the specialties 1. If it's not null, then it's OK. We just stop. If it's null, we fill it with the value of the specialties 2. If both of them are null, then there's nothing we could do. The output will be, of course, null. And so let's check how many null values we have now in the final column. Now we have only 21 of them, so we merged a lot and improved our situation. That's how it looks like. So the initial columns are specialties 1 and specialties 2, and the third column is the merge of them. So next thing which we are doing during the cleaning, we create some vocabularies of the values. So there are a lot of categories in our data: facilities, amenities, specialties. It contains a lot of distinct and sometimes not very distinct values, and it's pretty hard to work with all of them. So, for example, that's how the specialties values look like. So there are a lot of them. Sometimes they are the same. Sometimes there is a new value. Sometimes even more. I will hide it right now. Yep. So let's just save this to the specifications list. And again, we'll do our on my favorite double list comprehensions. Out of all this list of lists, we got only the list with all the values. So now it's in one list, and yeah, you can see that it's pretty a lot. I will again close it. And what we will do, we will just find the unique elements now. So when we apply the set, we get only the unique elements of the list, and we see that it got a bit smaller and cleaner. Most of the values are about someone being a superhost. Sometimes you see cancellation policy. Sometimes it says the free cancellation until some specific time. And again, superhosts. But now it's a smaller amount. And let's put them to the specs unique variable. Now, what we would like to do, we would like to filter out the useless values or rare values, which we probably won't use. And what we would like to skip, we would like to skip the something about the superhost, like these values, because this information we already have in a separate field, which we parsed before. Also, we would like to skip this cancellation policy word combination because it has no meaning for us. And there are also some house rules like, pets allowed or not allowed. We also would like to skip it because the house rule we were parsing in a separate column before. It also does make sense to do it here. And also we will slightly change or shorten the free cancellation strings. So as you saw before, the strings for free cancellation, they look like this. There is an arbitrary time, and we are not really interested in the specific value of the time. So we will just drop it, and we will be okay if there is any free cancellation. For this, we will create a simple function. So it basically iterates through the values of the facilities and looks, if it's a free cancellation, then put it to the list. If it's a superhost or house rules, then skip it, and otherwise just append it to the list. Let's see how it works on one of the rows. So that is a random row from the data set, and currently it looks like this. It has 5 values, 5 specialties. And when we apply the function from above for this row, we will get only 4 of them. So the house rules was eliminated, and also we slightly shortened the reconciliation one. So now we have only the things that we want and in the shape that we want. So it's kind of filtering out the unnecessary and cleaning the necessary. And now we apply it for the whole data set. So here I'm using the function apply. It's the easiest way to do now because I created the function and I'm just doing a lambda x function of x. And that's how it looks like. So now it got a bit cleaner. It contains only the values which we are interested in, and it's quite a limited amount of values. And the next technique is what we will use here is Hot Encoding. So probably it's something about the factor from our strings.
Igor, I have a question to the part above. You now were mainly inputting the already kind of structured information in on the individual page, right? Not the text down below. So when I imagine the Airbnb page, then you click into one location, right? And in the location you have then some structured information that you have been parsing here, right? Or structuring here. And then further down, you have like free text information that you have not been touching yet, right? The free text part, I assume.
I'm not sure if we're talking about the same things. So the raw data in on their website, looks like this. So that's what we parsed.
Mm-hmm.
Or you mean that this is already clean data? Or
I just looked at it from the user perspective when you're on the page, because I've been checking it according to what you're saying, and then you can see these categories: enhanced, clean, great location, great communication, which is kind of in the somehow structured format. And a bit further down, you have completely open text.
This one, yeah. Yeah, of course, we rely on the structure on Airbnb that it's only the specialties of the
specialties you have been out.
Yeah.
Okay.
Yeah,
because I could see, for example, it was also different languages in the open text. Up in the specialties, you have it all in English, but for this open description, you have it sometimes in German, since you're here looking at data from Austria. So this might be an additional trouble if you look into that. Is that correct?
Yeah, definitely. So for now, I'm not processing anyhow the description from the host or the reviews because they are free text, and we will have to apply some NLP techniques for that that I put to the side currently for this project.
Mm-hmm. All right.
Yeah, I have a very basic one. Sorry for that. So this Python notebook, is that, yeah, because you're using these process specialities in 51, and in this Python notebook, you basically can define functions and variables in one scope. So this is basically one scope, and you can reuse functions across it, or even variables. Is that
yeah,
how it works?
Basically, I have the kernel of Python 3 here. And yeah, it's the environment which I work with. Everything which I run here, it's kind of sitting in the memory of this kernel. And it's still there until I refresh it or restart it.
Okay. Interesting.
Igor, Michael has another question, a general question as well. He's asking about the API, the Airbnb API. We've been roughly discussing this last time, I guess. Maybe you just read it first.
Yeah, that is a totally valid question. So I would definitely get a cleaner data, but as long as I did my research, I didn't find any official Airbnb API. So at least the free one. So probably there is an API for the, I don't know, hotels or the hosts, but just for exploration means I didn't find any API. So of course it will be much easier to connect to their existing functions and use information, but we decided to go the hard way. And
also that scraping itself was also part of the project, right? You wanted to learn that.
Yeah.
That was one thing.
Yeah, exactly. So I wanted to do everything from the beginning, and I am not very proficient in scraping. That's why it was also quite challenging for me. Yeah. Good. So now we will jump to this one hot encoding. Yeah, as I said, I think it might be relevant to this factor of R strings. So what is it and when do we need it? A lot of information in the data frame is a text. So basically it's a categorical values. And this text is a bit hard to use afterwards in machine learning. So sometimes, of course, you could do it, but usually people try to preprocess the text to something which is a number. And one of the easiest way is as a technique, which is one hot encoding. So let's say we have this kind of string, and it has some fixed amount of values. So it's either Meyerhofen or Ischgl, or maybe there is some other value. And we would like to assign the specific number to any specific value in this string. So that is totally one hot encoding. There is an internal function getDummies in pandas. So let's see how it works like. It creates this kind of data set. So it just says that if it was Marhofen, then it says put 1 here and zeros to all the others. Or if it was Ischgl, put 1 to Ischgl and zeros to the others. So instead of the initial string, which was one of the values, now we have the 3 columns with numbers. And one of these columns is always 1, and one of them is, and the others are always 0. So this technique is called one hot encoding or REG. And that is probably the easiest way how to transfer the text information to the numeric information. There are different ways how to do it, but we will utilize this one currently. And yeah, so let's look at the column sequence specialties. I love the specialties. I don't know why. And yeah, so it's already a specialties clean, which we preprocessed on the stage before. And we would like to look at all the unique values in this column. So again, we will run this. Oh, it's not even a double comprehension, but no, it is. Okay, sorry. It's a double comprehension and a set. So these are all the unique values which we will have in the column. And now we would like to apply the same technique of hot encoding. We would like to know whether we would like basically to transform this text information to a numeric information. Yeah, I'm doing here manual hot encoding because probably there is some other way to do it, but I will just do it just like this. I will iterate through all the unique values here. And we'll say that if this value is present in our particular row, then this column will be 1. If not, then it will be 0. We'll quickly run it and see the results. So you see now that is our initial text value, and here are a lot of different columns, which specify, each column specifies only one specific specialty. Sorry for so many specific words. So clean, enhanced clean, entire home. Yeah, here's entire home. It's all one. Enhanced clean is also somewhere here. Enhanced clean. Now we have this sub data set, which contains numeric values, which are ones and zeros, and we can work with it in further steps, and we can put it to some machine learning model, and it would somehow work for us. And then again, back to our regular expressions. It's also, I totally agree with Alex. So one should not use regex only in some rare cases, but I think this case was worth it, at least for data analysis step. So there is the column price per night, and sometimes there is only one value in this column, but sometimes there are two values. I think that's an artifact of the way I did the web parsing. That's some additional HTML element which I accidentally took with it. But I know that the right value is always on the right. So it's either the only value or the value to the right. And for this, I decided to construct the regular expression. So I will explain how I did it. So a couple of steps. So first step, there might be the first price and the space after the symbol. So I'm talking about this 23 euros. So we say, hey, the price and the space, and 01 means that it could be 0 times or 1 time present. Then this price is either euro or USD symbol, and it has at least one digit. So instead of the price, we put here the symbols of the currency and the digits, and we'd say that there should be at least one digit. So plus means at least one. And then there should be always the second price. So we will code the second price basically the same way, just without the space in the end. And also we are not saying 01 because it's exactly, exactly 1. But what we want, we would like to extract not the whole thing with the currency symbol. We would like to extract only the number. So we put the currency symbol away from the parentheses. And that by doing that, we will extract only everything which is within the parentheses here. And the last step is basically to add the /night in the end. So finally, we have this regular expression. So it's the same expression. I just tried to put it in some different colors so to make it a bit more readable. There's the first part in red. That is the first price with the space, and this price might be not present. Then there is the currency symbol part, and then there is a part which we are interested in. It's in green. That's the price of the listing per night. And then there is just the word night. Let's check how it works on a couple of rows. So this is the initial row. And after applying this regex, we have the list of two values, basically what we wanted. And if there is only one value, we again have the list of two values. The first one is empty, and the second one is what we are interested in. let's just apply it on the whole data set. Basically, we did it for every column, or for every row, I'm sorry. And now we would like to extract the second element of this array and to put it to the column which I called price night euro. Actually, it's not correct because it's sometimes dollars, but that I will fix a bit afterwards. And that's how it looks like. So now we have only the number, which represents the price of the listing. Sometimes it's missing. Good. So yeah, guys, jump in because it was basically all the main techniques which I utilized for data cleaning here. Anything you come away ahead?
Thanks. Thanks a lot. Very interesting, actually.
A question regarding the last thing you did here. The numbers you include the euro sign for the left number basically, or the first price that comes in. But since you don't use this anyways, it doesn't matter if there's a euro sign in it or not, right? It will not transform everything to characters, or this doesn't matter since you make an integer out of it later anyways.
Yeah, right.
All right.
But yeah, but the thing which I did not do yet, now I have to decide whether the second one is a euro or dollar.
Yeah.
Or yeah, and apply the currency transformation. This one I will do.
And then one hot encoding is really exciting. I actually, because sometimes you can also use what we have been hearing before. You can use factors for this, right? Would be another representation of that. But you use something like one hot encoding mainly, for example, to do deep learning later on, right? That would be one case. What was your intention to go for one hot encoding here?
I think it's the easiest way how to transform the text to the numbers. Maybe, as if I understood correct, the factors will create the, like, I don't know, if you have the column which says the height and it will be low, middle, high, you will create the values 1 to 3.
Exactly.
That's what you call the So that's what you call by the factors.
And it's internally saved as a number, right? But in the view of the data, you can also translate it back and you see the actual, like, the text. So it's faster computation in that sense.
Yeah, I think I usually apply this technique when we're dealing with some value which is ordered. So let's say when you have the salary of the person, and it could be low, middle, high, and this low, middle, high have some meaning. So low is always lower than middle and high is always the biggest. Then I could code them as 1 to 3, because 3 is always bigger than 1. But when we're dealing with something independent, so for example, entire home doesn't anyhow depend on enhanced clean or self check-in, so they are completely independent. So I code them into zeros and ones to avoid any potential combinations or correlations between them.
All right. So one more question regarding one hot encoding, again from Sergio. He is asking for disadvantages in that sense. I mean, your data gets wider, right? But that's
that's a clear disadvantage. Yeah, I mean that's the biggest disadvantage. I don't know. So also, what might be the disadvantage that we all only have zeros and ones, and it's a bit, I don't know, too few distinct values of the elements. But it also is the easiest way how to go for it. So I don't know. I could think of some disadvantages, but
I mean, you also call this kind of bag of words if you have, for example, a 2 in there, right? You would embed basically the words into this space here, and you have 2, for example, for 2 words. Then it gets a bit more exciting about what the representation is. But so I would say the advantages are the data is wider. It maybe gets a bit bigger, the data, but in that sizes, I don't really see too many disadvantages. What could be a problem is if in one data set there is one word not included, right? and then you have your second data. So this is Meyerhofen right now, as I assume, what you've been extracting, and then you do it for the US, for example, for another like somewhere there. And then they have an extra category, and then you make this one hot encoding, and you have one more column, right? Or one column is gone, and then you try to merge these two data sets, and then you get a problem. So that could be with bag of words, you might have this problem sometimes, and bag of words is a type of one hot encoding in the end. That's just my NLP experience I had there.
Exactly, that will be a problem. That's so if you have you have your machine learning model which you train on some data, and then you have the new data, and if in this new data you have something new, then you won't be able to utilize this information, of course. Yeah, and you also have to think in advance a bit, so to build your model so that it won't break when it sees the new value in the training data. That is something to consider. Yeah, but you're totally right. And actually, I thought a bit. Actually, what I'm doing here, it's kind of a back of words. It's not directly one-hot encoding because we have kind of a text here, and I'm saying put the one to the elements which are present in this text. But it's always unique. That's why you don't have twos and threes and so on. But I think you could name it a bag of words.
I would say so. Yeah, definitely. I mean, there are more advanced ways of embedding real text, right? Written language. Here it's mainly categories, so we can do the hot encoding pretty easily. But when it comes to, let's say, written text, then you have to do kind of pre-processing in the beginning, because people might have like spelling errors. People might spell things differently that are actually the same. So that might be a problem, and also you can do then more advanced stuff like having bigrams or n-grams. So you put several words together and then look at different combination of these words, and you also put this into this embedding. But since here the order does not play any role, as we've seen, I guess, right? So the order is anyways, it's the same order, or it does not matter for us. Then this information we can easily we can neglect. We don't need to look at that.
Totally, I agree.
Very cool. Shall we maybe next to move to the Maxim's talk? What do you think, guys? It took us a little bit more time than we planned originally.
Yeah.
Igor, do you want to make a wrap up of everything, or?
I could do it very quickly, maybe.
A very quick one?
A very quick one. So yeah, so here we used a couple of methods which we will talk a bit above. So basically it was splitting the columns, and here are the columns which we will apply it for. Then it was a bit otherwise, merging or coalescing the columns. Then we also were filtering and applying regex things, and we will did one hot encoding or bag of words. What was a bit out of our scope, we didn't deal with duplicates, because when I will do the parsing of the same location twice, I will have to somehow get rid of the duplicates. Also, I omitted the conversion and scales, so this $euro and I don't know 9 p.m. or 21. And there might be also some typos. This was not the part of it. And as I said before, use SQL if possible. Maybe because I'm old-fashioned, I like SQL, and I would do probably some of these things in SQL. And also how to write pandas, clean pandas code. That's always a question for me, because all these things they look quite messy when you put them to coding. Yeah, so there are some results, just very quickly, very briefly, how they look like. And of course, I will put the script which I use for parsing to the GitHub page, and you will be able to look at it and see and criticize, or maybe something else. Basically, that's all from my side. Feel free to put me away.
We won't put you away, Igor. You will still stay in the group. It was super interesting. Thank you very much.
Thanks.
A lot of things I learned. I hope it was interesting for the audience as well. Thanks for these many questions. And now let's skip over to Maxime. You brought us something about finance, so I'm really excited. What is it all about? Can you give me a little bit of an intro about yourself and also about how do you get to the idea of the project and stuff like that?
Yeah, sure. So I'm currently working in Yandex as a data scientist, and I have prior experience in data engineering and a little bit of backend development. So I'm kind of like been all around the data world for the last couple of years. And at some point, I've decided to start investing my money to create a positive cash flow, personal cash flows. And well, as an analyst, I thought, well, why wouldn't I use my knowledge and my analytical point of view to achieve maximum value of what I do? So I've researched some classical quantitative methods of optimizing portfolios, and I've decided to implement one of the very popular quantitative methods, which is Markowitz portfolio theory, in programming language, and it was pretty easy because the idea behind it, it's fairly simple. I'll discuss it later a bit more deeply. And what I do then is I created kind of like interface to backtest different strategies, and well, yeah, I created some funny visualization, and I believe it will be interesting to see what I came up with. So it's not like a finished project yet. So there are certainly ways to improve what I've done, but it's kind of in a good spot right now.
Cool. Looking forward.
Okay.
Sounds exciting.
Let me share the screen. Do you guys see my screen right now?
Yes, we do.
Yep, I see. Maybe it makes sense to make it a bit bigger. Slightly.
What you mean?
Like the font, I mean.
Oh, I see. Yeah, sure.
Yeah.
Is it better now?
Yeah, I think it's much better.
Okay, cool. Okay, so I got here a brief intro. So let's go through it. Well, first of all, why would you want to invest your money in a stock market? Well, the answer is the history show us that if you invest carefully and thoughtfully, you will be able to surpass like bank deposit return, like in a big way, actually. And we are speaking about investment in dollars, but that's probably true for any other currency, and especially if you live in a country with which currency is not that stable, like Russia, for example, or Turkey is a big example. It's much more prominent to use stock market investments in order to maximize your richness in the future. But investing is actually hard. You have to do a lot of research, a lot of macroeconomics research, first of all, to achieve maximum value of what you do. And the second part, if you decided to invest in some particular companies, to buy some particular company stocks, you have to do a lot of research on this company and on the industry and on this company competitors and so on and so forth. It takes a lot of time to investigate all the financial financial stuff regarding regarding one particular company. And well, it's not for everybody, let's say. It's kind of specific world, let's say, this financial world. So what if you would not like to do all of this financial research? Well, you actually have what is called ETF. ETF is an exchange traded fund, and it's an asset that tracks some index, some financial index, or some sector, or some commodity price, or like whatever. So, for example, the most famous stock market index is S&P 500, and this index contain of like 500. It's not actually 500. It's a bit less or a bit more, but it's okay. Of 500 companies from different sectors in the United States, and it shows like the performance of broad market. So that's the most like well-known index. There are tons of different indexes for each sector and for each country and for each whatever. So an ETF makes it easy to invest in some broad amount of companies without actually buying the individual stock of each company. And why it's good? Because in order to build a well diversified portfolio by yourself, obtaining just particular companies, you will have to have like a lot of money. Like we're talking about hundreds of thousands of dollars. And well, if you're not very rich, it's not quite appropriate for you. But you can use ETF, because one ETF of for S&P 500 index could cost like $300. Well, $300 is much more affordable than $300,000. So that's why ETF are cool, and you most likely have to use it if you'd like to invest in stock market. Okay, so yeah, I do understand that I talk very quickly right now. So if you have any questions, please feel free to ask them. As we don't have that much time left, I try to speed up a bit, but it's okay if you interrupt me. Okay, so how to evaluate whether our portfolio is good or bad? I use like three main metrics. One metric is a very convenient, is return of a portfolio. So that's it. That's just how much money does this particular portfolio return. The second one is volatility. Volatility is a measure of how let's say unstable are our returns. So from math point of view, it's just an usually standard deviation is used, or variance is also okay. So basically the idea is the more volatile is the asset, the worse, because you know, it's kind of scary when you buy an asset and it jumps like 20% up and down every day. It's you are not sure whether the price will be stable in a long period of time. So basically you would like asset to be like less volatile, but at the same time you would like the asset to bring you more return. So it's kind of a trade-off between risk, which represented by volatility, and your returns. And to represent this this trade-off, one can use another metric, Sharpe ratio. And basically, Sharpe ratio is a metric that tells you how much of a risk you will take for each percent of a return. To be more precise, we use not the returns itself, but returns minus returns of risk-free asset. Risk-free asset is basically cash. So the idea is you can always have cash, and like do not bother invest in something. You can like just invest in short-term treasuries, United States Treasury bonds, and be kind of fine in terms of risk. But at the same time, you will have a very low return rate. So that's a trade-off. Okay, so let's move on to some code.
Maybe one comment, Maxime, because you've been talking about, okay, what is the problem with volatility, right? And maybe it helps if people imagine volatility as risk, right?
Yeah,
you can say volatility is equal to risk, because you don't know if you will get the return that is promised over a long period of time.
Yeah.
So
exactly.
You want to cash out, I don't know, next year, you want to buy a car, build a house, or whatever. But the volatility will represent the risk that you will have a low output, actually, right? A low
exactly.
return.
Exactly. The problem with the risk term is just it's not very concrete, let's say, and volatility have like pretty well defined math meaning. So that's why
Agreed.
I used word volatility. But yeah, you can interpret it as a risk.
Agreed. Then one more question. You've been speaking about Markowitz portfolio as well.
Yeah.
Will you come to that later, or because I would have a question there?
Yeah. Well, I will talk about it very briefly, but probably it's a good time to ask it right now. Probably. So.
All right. Perfect. So as I understand Markowitz portfolio, you always have, or you try to compare two stocks, right? You compare two stocks that are negatively correlated.
Well, it's actually I interpret it as a iterative process. So on the first iteration, yeah, you have two stocks, and you decide whether to add another stock in your portfolio. So, like for example, you choose one stock, then you have to decide whether to choose like this stock or this stock or this stock or this stock, and you compare pairwise them. And then when you found one that you would like to add to portfolio, you will move on to the next stock, and then you will have to see whether your portfolio containing two stocks is like well correlated with another one, and how yeah. So
All right,
for me, it's iterative. It's iterative process of adding stocks into your portfolio.
If you think of the data science equivalent, it's something like feature selection, right? You think about, shall I use this new feature or this new stock in my portfolio? Does it add value, or does it just add risk, which is technically speaking variability? Or volatility.
Yeah.
All right. Interesting.
Yeah.
Good.
Okay. So let's move on. I do use some some stuff which mostly is pretty standard. I use pandas to do some data processing, and pandas have a very good library which actually can make you allows you to download data from different data sources in very convenient and easy way, and I'll show you later how to use it. I use NumPy, which is a math related library which allows us to manipulate our data as math objects, like as vectors or as matrices and so on. And I use this optimization library to optimize my portfolio, and we'll move on to this later. And also Matplotlib for visualization is just a visualization tool, nothing more. Okay, so here I have a list of different ETFs I use in my project, and here in the comments I have a reference to index, which is the benchmark for each ETF. So, for example, we have ETF SPY, and it tracks S&P 500 index. So this particular list is quite random, I would say. I just choose some of ETFs I know, and make sure it's quite broad number of ETFs. So it has broad indexes. Here it has some commodities here, like gold and silver. It has like semiconductor index, and it has like I don't know, like banks index, and so on and so forth. So we have a whole bunch of different indexes here. Okay, so now interesting part come into play. So I have pretty large amount of stuff like that, like different classes, which makes my life a bit easier with this project. I will not dive deeply into every class here. I will just briefly describe what it does, and we'll more deeply in important classes a bit later. So this one is just basically it contains some information about dates. Basically that's it. So it has three important attributes with this start date, end date, and test start date, which is start date of testing period, and we will talk about it a bit later. I have price frame class here. Well, price frame is a reference to data frame, and basically it's a wrapper, not a wrapper, but it contains a pandas data frame inside, and well, it just makes a bit easier to manipulate with this particular type of data here, which I use, which is financial data. And so how does it do that? Well, it has this fill function, fill method, which iterates over tickers and uses data reader, which I talked before, to download data from Yahoo Finance, which is a pretty good source of financial data, pretty rich. So basically that's it. It iterates over tickers and for each ticker, download data from Yahoo Finance, and it's you can specify like the time frame for it. So I say like download from start date till the end date. This is just technical stuff. Okay, and then I have some attributes which will help me later in my research. So I have like list of tickers I use, amount of stocks here in this data frame, and I use logarithmic returns to calculate like as a measure of my returns. Why it's logarithm? Because logarithms are easy in terms of math. You are able to annualize this data pretty easy, and in order to compare some different time intervals returns, you will have to annualize it to make it more readable and more convenient to use and to understand. So if you use like logarithmic returns, you can just multiply your mean returns, which represents return for every day, and multiply it by I believe like something like 250, which is amount of days stock market is open every year. So okay, what's next? Let's see how it actually works. And here I use like this dates info class, which again is just a class with bunch of attributes, like nothing really special here. Okay, let's use like this date, the first January 1st of 2011 as a start date. Why this date? It's just because I wanted, so it's like there's nothing important that happened on this date. Let's use today date as a last date, and let's create a price frame with our tickers and like this date, and let's fill it. So I've already done this, and here we are. That's our data frame, and as you can see, each row contains data of a price of each for each ETF, for each ticker. So yeah, it's a daily data. Like every day is another row. Okay. So, and what we can actually do with logarithmic returns is do this. Like, let's say we would like to calculate how much of mean returns each ticker gave us for this period of 10 years. And we can just take logarithmic returns, take mean of logarithmic returns, and multiply it by amount of trade days. And so here we are. For each ticker, we have its return. So it's very easy to see what ticker delivered most income for its holders. Okay. So now we have
one question here regarding the logarithmic returns. I assume when you do not use logarithmic returns here, you could not do this transformation, right?
Yeah, exactly.
You cannot like multiply it with the number of days traded, because the returns grow and grow, because most of the funds are I don't know the English word in German, it's thesaurierend, or reinvesting, right?
Mm-hmm.
And so you could not follow on, okay, was this because it performed the last year's good and then the performance in the next years is also better. So it's self-investing. You go against this trend of the general market, right? Is this the reason why you use this?
Well, not really. The reason here is purely mathematical. So imagine you have like not logarithmic and just usual returns here, and if you take a mean of these returns, like, okay, so let's actually take a look. Give me just a second. I'll do this. Like, let's take a look on logarithmic returns here, and let's take a look on usual returns here, like non-logarithmic. And let's take a mean. Okay, so what we have here is just you can't quite interpret well what you see here. Like, let's take a look at returns by themselves. The problem is you actually cannot sum, like, for example, these two numbers, like 0.99 and 1. You cannot sum it and say that the return of these 2 days is the sum of these two returns. You cannot do that because it's like
I mean, the return is negative in the first place, right? 0.99 means you have 1 minus 0.99, so you have 0.006 or something like this as a return, minus, right?
Yeah, minus.
And then the next you would have plus 0.000 or 0.005 or something like this. But you could add this up, right?
Yeah, you can add up, but it will not result in a return of these 2 days.
Yeah.
You can add up and take the mean, but it will be a number which is close to 1, and all the numbers which will be close to 1. So I suppose there will be a low variation between them.
Yeah, exactly.
And if you divide one by another, you will have quite distinct values, which will show you how it really changes from day to day.
Yeah, exactly. So if you take logarithmic returns here, you can actually do that with them. So if you sum all of this, like, and take a mean value, you will actually obtain like the what it should be. It's like a mean return every day, and if you multiply that on trade days number, what does it mean? Well, it's logarithm, right? So logarithm of product is sum of logarithms. So you can multiply this by this number, and you will actually have, from math point of view, correct estimation of your returns each year, like yearly returns. So that's why we use logarithmic returns and not normal ones.
But everything is now transferred into logarithmic, so you cannot use you cannot compare this to regular numbers anymore at this point. At least, right?
Yeah, the idea here is logarithm of like these not very large numbers are kind of close to the numbers themselves. It's not like quite the same for sure, but it's kind of close. So actually S&P 500 wasn't like exactly this amount of percent each year for last 10 years, but it's close. And the main part here is to be able to see whether, like, to compare different forms of portfolios and different assets, and that's the way we can actually compare it pretty easily.
Thanks. Good explanation. Yeah.
Okay, so let's move on. I have some like some utility classes here, which helps me like print basically my stuff in a convenient way. And at the beginning of my project, I had to write down all of this like ugly stuff every time I'd like to see what's going on in my portfolio. So it was awful. So that's why I created a couple of these utility classes, and they are not that interesting in terms of project. It's just in a matter of like code code quality. You know, it's just for the sake of good code. Okay, and that's like the same thing, and that's a bit more interesting. It's just it's another utility function that helps me understand whether I pass correct data to my class, and it's kind of complicated, and we'll not go through that right now. Okay, so here is like interesting part: complex portfolio. At some point, I've decided why not use data from different period of time and combine it in some way so that I will have several different portfolios, and each of them is optimized on its own dates range rather, and then combine them all into one portfolio using some weights. Why would I do that? Well, I've decided to test the hypothesis that if you take into account more recent data, it will help you to identify some short-term trends, but at the same time you would want to use some like more historical data on a wider period of time to get some knowledge about like more fundamental trends, let's say. That's why I've decided to create this class, and it has like a lot of different attributes, but let's see what it actually does on a more like abstract point of view. So it takes date splits as an argument, and date splits is basically a list of strings, and each string represents some date. And what it does is it iterates over date splits, and it creates a price frame. Remember, price frame is just a wrapper around data frame, which provides us convenient way to access data. And let's create a price frame for each date period from dt, and dt is an iterator over this list till the end date time. So basically, if you have like, let's jump to an example, so it will be more convenient. Okay, so for example, like just give me a second. Oh, no, I just made a mistake. Let's see here in our price frame, not price frame, in our dates info class. So that's where we define the splits. So here we are. Let's take what happens here. Like I will do this for a moment. What happens here? Speaking of not well readable code, we take an array which contains of our test start date minus different amount of months or years. Like for example, here we take our test start date and minus 2 years. This minus 1 year, this minus 6 months, and this minus 3 months. So it creates a list with 1, 2, 3, 4 dates, and one of them is like 2 years before our test start period. Another one is 1 year, another one is 6 months, and another one is 3 months. Why these particular numbers? I don't know. It's just my like perspective, and I will sure be improving this later, so that I'd like to find out what periods are actually good to estimate long-term trends and short-term trends and so on. But for now, it's just like 2 years, 1 year, 6 months, and 3 months. Okay, so we create an price frame for each of these date periods. Here we are, and then we run our optimization function, and we will talk about it a bit later. Our optimization function for this particular period of time. And then we create a list. Like this attribute is a list of different portfolios. And each portfolio is, again, optimized on each every particular time frame. Okay, so yeah, and what we do here is just we take our weights. Like for example, imagine we have 3 portfolios, and one of them is like for a long-term trend, another one is for mid-term trend, and another one is for short-term trend. And let's say we would like to give more weight to our short-term trends. So we will give our weights like something like 0.3, 0.3, 0.4, for example. And we will see the examples of these weights a bit later. Okay, so that's pretty much the main class here. What it does is it takes price information and optimize the portfolio in some way. Let's take a look. Here I have like random portfolios generator. It's just for sake of visualization. We will see it a bit later. What we have here is just create a random array and then normalize it. So it's like every part of it is a number between 0 and 1, and sum of these numbers will always equal to 1. Then let's calculate the return rate of this portfolio and standard deviation of this portfolio, or volatility or risk. And this one particular line, it's kind of non-intuitive, and you will have to do some math in order to understand why is it so. But basically, it's this formula represented as a code. And why is it represented this way? It's just a matter of math, let's say. So if you want to, you can always explore this. It's not very It's not very hard, but you certainly have to be familiar with some vector type of math, and we'll not dive into it for now. So we create this portfolio, a lot of random portfolios, and returns of each portfolio, and the standard deviation of each portfolio. It's just a function, a method for plotting things. It's not very interesting. If you are familiar with the matplotlib library, it's very familiar for you. But if you are not, it's just a number of comments which tells what kind of chart you'd like to see. So, for example, for here, for this particular example, we have our random portfolio values. So one of them is standard deviations, and another one is returns. And I'd like to plot a scatter plot using this data, and color it to represent the Sharpe ratio we talked before. And we will talk about why I do that a bit later when we will talk about our visualization. Okay, so and then I just label my my x and y axis in a way it's like convenient for anyone to understand the chart. Okay, so another one, we have portfolio stats, and this one is just taking some portfolio in terms of weight. So basically, what is portfolio? It's some list of weights corresponding to each asset. So I take this weights and I just calculate return and standard deviation and Sharpe ratio in a way we talked already. So it's quite simple. Here I have some let's say target functions to optimize. I have 3. So one of them is it's actually have to be max Sharpe. I don't know why is it min Sharpe. One of them is to maximize Sharpe ratio. Another one is to minimize variance, and another one is minimize standard deviation. So it's quite convenient also, and we will talk how to use these forms of functions a bit later. Actually, we will talk about it right now. So what we do have here is a optimize function, like one of the main tools I use, and basically it's a wrapper around about minimize function from the SciPy library, and let's see what it does. It takes some amount of arguments. The first one is optimization, is function to optimize, and that's actually will be one of these 3. I talked a bit earlier. Another one is a starting point of our weights, and I actually use just equal amount of every asset as a start point. We won't talk about methods right now. It's just another pretty large topic here, and we don't have any time for that, unfortunately. It also have bounds. So what is bounds? Bounds is just some conditions which have to be maintained while we optimize our function. So in our case, we would like any like any weight in our portfolio to be between 0 and 1 for obvious reason. Not well, okay, it's actually not that obvious, because you can actually short assets. You can short sell assets, and it means that you can go actually with negative values in your portfolio, and as well you can use margin money, like borrowed money, to buy assets even more, if you like, so that it sums up more than your initial capital. And but okay, let's forget about it for now, because it's kind of hard. Every broker has its own margin, like let's say margin account settings, and you will have to adopt to your particular broker, and it's just too hard to code all of this stuff, so I just left it to these bounds between 0 and 1. But actually you can do stuff like that, or like even that, something. So, but again, it will not work very well if you leave it in this way. So you have to adopt to your broker. Yeah. Okay. So yeah. And constraint is just like what it means. It's just a constraint on our functions, and it you can initialize it in this way. So I use personally this type of initialization. I believe there are some different forms of how you can initialize your constraints, but it's like the basic one. So what happens here is we say that this type of constraint is equality. So our function in sum should be equal to 1. Yeah. So that's again a matter of non-marginal accounts, and if you use marginal accounts, you can surpass this constraint and not use it at all. But like for our project, let's think that you have your own money only, and you are not short selling any assets. Okay, so and this one here is okay. It's just it's a constraint for our what is called efficiency frontier function, and we will talk about it like a bit later, and I will explain what all this stuff is on a chart actually. Okay, so there are some functions for plotting. They are not very important. They're not very interesting. So that's actually a function for getting optimal portfolios, and we will. I always use two optimal portfolios. One of them is optimized by Sharpe ratio, and one of them is optimized by variance. And as you remember, I have different methods for each of those. Each of this method. Okay, so and I always have two optimal portfolios. They are optimal in a different ways, and you will see on the chart very soon how it looks like. Okay, so I have very little time, so I have to speed up a bit. And this is just a plotting function. Again, it's like not very interesting. Okay, so here is like the main wrapper function, which which creates all the stuff and runs all the stuff, which is important to optimize portfolio. And if you recall, I used this particular function in my complex portfolio class, which creates different portfolios for each time frame. So here we just create an optimal portfolio from these prices, which we pass to this function, and then we create a report for this optimal portfolio. Report is just a class that makes printing and like printing easier. Basically, it's just doesn't have any additional data in it. And you can also like plot or not plot some stuff, and we will talk about these graphical charts very soon. Yeah, this is just a purely utilitarian things, just not to create random portfolios each time and not optimize stuff each time. If you reuse the same class instance, it will use like cached data to speed things up a bit. Just yeah. And this one is the main function for backtesting. So what we do here is we create an optimization report for our control period. The control period is like, in a sense that we use this word in machine learning, for example. So like when I talk about test period, I talk about period which we use to optimize our portfolios. And when I talk about control period, I talk about period I'd like to use to evaluate whether our portfolios were good or not. Okay, so so yeah, that's basically what this function do. Okay, and here I have a backtester, which actually just wrap up all we have discussed before. So basically, it takes price frames for each like for test period and for control period, and then it runs all the stuff. So it creates different portfolios with different weights, and then it's like do all the stuff we talked about before. So it's just a wrapper function which sums up all we talked before. Okay, so finally we can see some interesting stuff, some funny things. Okay, so I created several periods of time, several time frames to see how all this stuff works on different time frames. So what I have here is 4 periods of time. The first one is basically the period right when COVID-19 crisis started to affect markets in a big way, and it happened on 20th February of 2020. And this was like the last day before large correction, which happened in late February and March of 2020. So like this, this is it. And I use January 1st as an endpoint of this period. So basically, this means that we would like to create, we would like to optimize portfolio on a date range between, just for reference, start date is this number, this date. So we would like to create, would like to optimize our portfolio on a date period between 2011th year and this date, start of the correction. And then we would like to see how this portfolio will work if we like create it on this date, and then let it go till the January 1st of 2021. So basically, why would I want to do that? Basically, I want to use this framework to create a optimized portfolio, and then I'd like to be sure that next couple of months, like 3, 6, 9 months, this portfolio will perform well. And this backtesting framework will allow me to see whether in the history, if I do like the same thing, I will succeed or not. And here I have some like different periods of time. Like the other one is time period before COVID-19. So as you can see, it ends right at the same time as this, like as I use here. And we also have a time period for 2019's bull market, and pretty much all of the 2019's like first periods, like first half of a year, was a very good bull period of time. So everything like grew in a very good way. And we also have bad times, let's say. So here we have like 3 months of a pretty large correction, which happened in late 19th year of 2019. I'm sorry, 18. Sure, 18. Okay, so let's see. Yeah, and we have these weights. Basically, what it means is just we will have 3 portfolios. One of them is optimized on like longer period of time. The other one is like equally weighted for different time periods. And as you recall, they are like 2 years before, 1 year before, 6 months before, and 3 months before. And this one is like heavily overweight by shorter term portfolios. Okay, so let's see how it works on our first time period, which is post COVID-19 period. And we have like this chart. Okay, so what's going on here? This cloud here is just our random portfolios we generated. It's just, you know, like 5,000 random weighted portfolios, and it's it. This yellow star represents our benchmark, and as a benchmark, I chose S&P 500 as a like most commonly used broad market index. This line here is so-called efficiency front, and it contains of portfolios which were optimized, which optimized its volatility for a given return. So let's say I would like to know what's the optimal portfolio which returns like 30%, for example, in terms of volatility. And like this one is actually, yeah. So is just created of like I believe 50 portfolios, which and each of them is optimized with these constraints. And the color of efficiency front and of this cloud of random portfolios is just a Sharpe ratio. So the more yellowish it is, the better. So the more sharp is, the larger this number is, the better. And we have like these 4 large dots here too. So these circles are optimal portfolios for this period of time. Like in this case, it's remember from late February to the beginning of this year. And the red one is optimal in terms of Sharpe ratio portfolio, and blue one is optimal in terms of volatility. So you can actually see how optimal it is, because it's like on the very edge of our efficiency frontier. So you can basically you cannot go left here, more to the left than it is right now. Okay, so and these triangles is the same thing as these two. So the blue one is optimal portfolio in terms of volatility, and the red one is optimal portfolio in terms of return. But if these two, like these circles, were built using our test data, so it is actually optimal for this period of time from February to January. They are actually optimal, but there is no way you would know it is they are optimal beforehand. Yeah, so you can see that retrospectively these two were optimal, but you sure have no chance to know that these two will actually be optimal for like next 9 months, for example. And there is no way to do that. But what you can do that is what I did, is to create optimal portfolios using the prior data, like the historical data. And so here we are. Again, like I have 3 charts here. You can interpret them as this chart is, and they are all the same except for these triangles. So these triangles are for portfolios which are optimized in terms of long-term cycle, long-term trend, and this one is like equally weighted, like longer and shorter terms are all equally weighted, and this one is heavyweight short-term portfolio, short-term optimized portfolio. So how to read this chart? As you can see, like on y-axis we have return, and on x-axis we have volatility. So the higher return is better and the less volatility is better. So this random cloud is basically what I use to determine my return if I will not think at all about creating my portfolio, and I will just randomly create it. So what I would want to do is to be either higher than this cloud, because the higher it is, the more returns it is with given volatility, or I would like to be on the left side of this cloud, because on the same level, on the same horizontal level, because it will mean that I have the same return but will have less volatility. And let's take a look. So these two points derived from our historical optimization are actually far to the left to this cloud. So it means that if I did this research like on the 20th of February in 2020, I would be able to create a portfolio which is far less volatile than average portfolio on the market, and gives actually the same rate of return, which is quite good. Even more, if we look again on our benchmark, which is S&P 500, which is here, it did not perform that well. It actually it's quite bad. in terms of risk return. So we would be able to outperform our benchmark even with our conservative portfolio, which is optimized by volatility. So yeah, that's like the first time period. And yeah, let's see on the like very briefly how it looks like. So let's take a look on this particular portfolio. So it's like the last element in our list of portfolios, and I just want to see like the portfolio itself. I just want to print it. So that's why all of these classes were created, just for this interface reasons. Okay, so what we see here is we see two portfolios. One is optimized by Sharp, and the other one is optimized by variance, which is the same thing as volatility. So I can see like stats of this portfolio. I can see like log returns. I can see volatility, and I can see Sharp ratio. Like these stats are not very good because this time period actually has this like month-long correction period, which were held in March of 2020. So at the time, markets actually lost about 50% of its capitalization. So that's why these returns are not very impressive. Well, it's still good, but yeah, Sharp ratio of 0.6 is not very good. Okay, so we which is like the most important thing, we see here the actual weights on every asset. So yeah, it's pretty convenient and straightforward, I believe. And if you take a look in this correlation matrix, like on this covariance between every asset, you can see actually that like some interesting stuff. For example, this asset, which actually is gold ETF, it has very like even it can have even a negative correlation with a lot of other assets, except for silver, by the way. So that's why we have a lot of gold here, just because it's very bad correlated with other stuff. We have triple Q, which is ETF for Nasdaq 100, and why we have it? It's like very easy. Like let's do this. Oops. Let's do this and take a look on our returns for this time period. So, well, that's the answer why we have a lot of Nasdaq 100, because it has like very good return rate. And if you take a look, by the way, the gold actually doesn't have that impressive return rate, but it still have a very large weight in our portfolio, just because it's not very correlated with other stuff. So, and another assets are just like the rest of it. It just does not have the same weight, like the same large weight as first two. And the variance portfolio is like kind of the same thing, but with other assets and with other weights, obviously. So, for example, here we have much more gold. Almost half of our portfolio is contains gold, which is, well, a bit of overwhelming, let's say. Okay, so and here I have some I'm already rounding up, and I have some another examples for other time periods. So here we have.
Maybe I can ask one question in between,
sure.
or one remark. So
Sure.
my intuition is that the EAU, so the gold ETF, you would have in your portfolio because it's negatively correlated, and so you get your variance down, right?
Yeah,
You
exactly.
get your volatility down if you combine two portfolios that two assets that have a negative correlation, because yeah, it goes further to the left.
Yeah.
So that's the intuition behind it, right?
Yeah,
So
exactly.
the less, okay. So probably the less you optimize for the least variance for a given return. Is this the way you optimize, if I remember correctly, or was it the other way around?
Yeah, but that's the way I used to build this efficiency line. So efficiency line is basically you cannot go further than this line. You cannot go like in this area, for example. Because here it's like the most like the least volatile portfolio for this amount of return. So you cannot obtain like let's say 0.3 return with 0.2 volatility. It's just not possible. So
you assume a return, and you want to get the optimal portfolio that has the least volatility.
Yeah,
right?
Exactly.
Okay. So I assume the less return you want to have, the more the higher the or if you accept the least amount of return, you will get a very stable portfolio, right? A very less volatility, and on top, probably the gold part will be very high, because this brings down your volatility. Is this correct?
Exactly. Yeah, exactly.
Okay.
But the interesting thing is, as you can see, this line actually it's not monotonously growing. It has like this tail, and all
can't
of
forget
these
about that,
portfolios,
right?
Yeah, and all of these portfolios actually are far worse because it has like very little return with large volatility than, for example, like these portfolios. So they are very bad, basically.
Yeah.
Yeah.
Right.
Cool.
Yeah, makes sense. What was the portfolio which you had a very huge gold share in? So what was the for what did you optimize when we had this huge, we saw this huge gold share?
It was optimized for volatility, and it's like this one.
Yeah, but
like
for short term, or how was?
Well, we discussed like this short term trend. Yeah.
Okay, that's what we saw when we looked at the portfolio.
Yeah,
right.
we can see actually like our what our longer term portfolio looks like, and whether it's different or not from our short term portfolio, or how different it is. Okay, so let's take a look. For example, like this Sharpe ratio portfolio here is for a short term portfolio, and this one is for a longer term portfolio. Yeah, so it's quite different, as you can see. Like it has far less triple Q. It has far less gold, actually, which is kind of funny, and it has like some other assets which are not represented in our short-term portfolio. So yeah, you can play around this. Like that's all premise of this project, is to see whether you can obtain some insights from playing around different time frames and different like all of this stuff you'd like to tune down or up a bit. You can play around it, and it's very fun, actually.
Super cool.
Okay, so last thing is another couple of examples. So as you can see here, in this particular example, our optimal in terms of Sharpe ratio portfolio did not perform that well. It actually appears in the middle of our random cloud, and it was beaten by our benchmark, but our volatility optimized portfolio is actually very good. It's like it's very close to actual optimal portfolio, and it's quite interesting. And as you can see, this trend that like low volatility portfolio actually stays low volatile, so they are not becoming for some reason more volatile. It actually is everywhere, like every time frame. As you can see, this blue triangle is very close to blue circle, which means it's really close to optimum, to an actual optimum. Yeah, so here the same thing. And here is an interesting example, because here I took a very bad period for the market. So as you can see, annualized returns for random portfolios and for our benchmark, it's very bad. So it's like far to the right and down side of our chart. But again, look at our blue triangle. Again, it's far more to the left, and it's actually it's not that bad in terms of return. So yeah, and it doesn't really change depending on time frame, on whether you use like short-term trend or long-term trend. And it's very cool, because it means that if you think that correction is near and you would like to be more conservative, you actually are safe if you use historical time frame to determine like which conservative portfolio you'd like to run. So it's very like good knowledge, and it's very good insight from this project I have so far, like the best one probably. And if you look at Sharp optimized portfolio, it's kind of not that stable. So it can be like here, it can be here, it can be here, like all the way around our benchmark and random portfolios. But if you look at our minimum volatility portfolio, it's always like it's always close to the actual to an actual optimum, and it's very cool. So I believe it's it for me. Took a bit longer than expected, but yeah.
A bit, but it was all interesting. So very cool outcome, very tied to current situation, and also eventually gives some of the viewers and also us a bit of an indication how to invest eventually, right? And if we would have your script, we can
so.
eventually run it and check it out, what this would mean, for the next I don't know, correction or whatever happens. Super interesting. Then there was this one exactly, Michael was asking this exactly. Do you have this available on our GitHub?
I will push it there soon.
Perfect.
Great.
Yeah.
And he's also asking, I can push the question here. He's asking if you used Yahoo Finance.
Yeah, exactly. Again,
and if Yahoo Finance also tracks cryptocurrencies. This is his question, I guess.
Yes, it does track cryptocurrencies. I personally don't invest into cryptocurrencies, but you can use like the very same interface to deal with cryptocurrencies as well. Yeah.
Mm-hmm. Would be very interesting to have a Markowitz portfolio with cryptocurrencies. I'm very interested. Probably it would be more interesting to check it with some other assets, because there the correlation would eventually be lower, or actually more negative. I think from a logical perspective, it would make sense. Yeah.
Well, yeah. I just wanted to have some like sensitive limitation to our to my array of ETFs and my instruments, just because I think if you use this stuff on like, for example, if you take like all of the available ETFs, for example, like there are hundreds of them, and run this thing, I don't think you will get some insights from it, just because it will be too noisy. So from my point of view, you have to choose some amount of good ETFs, for example, what you consider as a good ETF, like the largest one, for example, or something like that, and then run this thing, and not just like mindlessly use it on the I don't know, like on 6,000 available Nasdaq and New York Stock Exchange assets. So
yeah, makes sense to me. Yeah, Alexander is also asking, will you make the code available? And yes, I guess the answer is yes. This will be on our GitHub. Very cool. And then one more question from Sergio again. He is asking if you intend to build an app for this, or make it available somehow else for users that are eventually can run the code or something.
Yeah, I haven't decided yet. I have some ideas about creating like some form of an application, or like Telegram bot or something like that. But I'm not sure at the moment. Probably yes, but I can't say in what form and when will it happen.
What was your dream? So what would you say was the best thing? Having an app, a web page, or?
Yeah, I believe something like web page, which allows user to play around like different types of assets and different lists of assets and different time frames and all of this stuff. Probably something like that.
Super cool. Very exciting. Yeah, I guess we're coming to an end. Also, my battery already exhausted of my camera, so this is normally a sign that that we come to an end. It was super interesting. Igor, thank you. Maxime, thank you very much. We will probably see again in 2 weeks when we have our next talk. And until that, any last points you want to mention to your projects, maybe?
Thanks a lot, Sebastian, for hosting us. It was really awesome. And thanks, Maxime, for a project that's really cool.
Thank you, guys. Thanks for listening. Thanks for asking questions.
Thanks for all the viewers on YouTube and for your questions. It's really awesome to be interactive. Thanks a lot.
Yeah, it was a great session. Have a good day. Have a good weekend. See you all. Bye.
Yeah. See you. Bye.
See you guys.